Hey y'all, sorry for the late stream. I was having some issues, technical, so it should. Alright, so today, this is working. Just get. Edit this as well so you don't have to hear me. Just, right, right. So today, Pythagorean Theorem. I'm not gonna talk about that because I missed you all a lot, a lot. So let's just I'm gonna do a review stream for now, but as of right now, so I'm not 100% sure. Get through this, like I said earlier, it's very fluid. So it's just but I'm gonna make sure y'all are gonna be learning. I'm still gonna keep doing these for y'all, at least when I can. Um, and I am gonna go over pre-algebra stuff today for a little bit, and then I'm gonna go into algebra. So the pre-algebra stuff I'm gonna do is Pythagorean theorem. I figured I would go through is it a right triangle? How to figure out that, and then how to do uh, whether or not you're trying to find an actual side. So with that, and then for algebra, chat go. There it is. Okay. I will make sure y'all get all the material you need. Like I said, I'm gonna keep doing this, and if there are new lessons, cool. I'm gonna have the one thing I'm gonna have to look into is how to get y'all because some of y'all only have access to the Chromebook, so if y'all have any insight as to what other stream service I could use instead in case people can't use it because I know YouTube's blocked, I'm gonna try to email some people today just to see if they can at least unblock my channel, and then I'm gonna try to see if they'll do it for Twitch too. See. Um, anyway, I'm getting off topic. Algebra, we're gonna get into radicals. And we're gonna do radical expressions. I mean, depending on whether or not you think polynomials are going to be important in life, it's up to. I mean, I know there's the TikTok that's out there. It's like, what's 3 things you use in life? And it's funny you didn't say calculus. So I don't know if polynomials would be one of the things up there, but you know, they would be important, especially if you go into science or engineering, or if you want to continue on into past algebra 2 calculus. All right. Anyway, so let's get set up. Let's do Pythagorean theorem first. So Pythagorean theorem is when right. Oh, perfect. Start. Thank you. Look, it's dealing with right triangles. You have an A, C, and so A squared, squared, C squared. That's what Pythagoras found out. He found out if you square each of these lengths along your triangle, you can find the length other side, except we're going to have this operation. So he basically said that if I was to draw this out instead of, so if I took A, box, because that's what happens when you square it, taking the area. square. So say it's 3. That's a 3 by 3, so that's 9. This bottom one, say that's squared. So if I squared these two sides and added them together, then the square of this length, which it's kind of awful since I drew it, would equal the square of this. So this is actually going to be 2, 2, 3, 4, 5, 2, 5. So it would add up to be the same on each side. And I know that looks absolutely awful. Sorry for that. This. So that he came up with this formula, this theorem, to allow us to find out each side. So if you're given the numbers and you're asked if it is a right triangle, oh, and I should go down. So A and B are your legs, and you know they're your legs because if you were to do a squat or sit in a chair, your legs would make a 90-degree angle. That's how I usually tell my students to remember that. And then across from the, I can, four people are watching right now. So you have your legs, and then you have your hypotenuse, which is across. So let's label leg. That's so. This is a leg. And then you have your hypotenuse. And usually we have an arrow that you can draw from the cross. Yes, and it is also, the hypotenuse is also the longest side. Very good. So, and that's so the longest side will always go in for C if you're given 3 values. So if I have something like a problem asking, so is the following a right triangle, and they give me something along the values 6, 8, and 10. I'm going to plug each one of these into a spot. So 6 and 8 are the lowest 2 values. So I'd plug those in for A and B. Plug in 6 for A. You could plug in 8 for A. It's up to you, but it's as long as they're on the left-hand side. And then on the far right, our longest side is going to be 10. So now you're going to square them. So 6 squared is 36. Plus 8 squared is 64. Or 10 squared is 36 plus 64 gives us 100. So if it's a true statement, then it is a right triangle. If it is a false statement, then it is not a right triangle. So if I had something like down. 5, 13, 12. This time they didn't give it to us in numerical order. So because they didn't give it to us in numerical order, we got to remember our longest side needs to go in for C. So A squared plus B squared C squared. So hello. So for A, I'm gonna put I'll put 5 in. 12 in for A, and then 13 will be for C. So 5 squared plus 12. Oh, I even messed this up, y'all. Let's try this again. So squared is 5 squared squared. 12 squared is 144. 5 squared is 25. 13 squared is 169. And then you can just add these up. So 144 plus 25 actually gives us 169. That to be a true statement. Now, if, let's say, well, Mr. Parker, I don't remember perfect squares in my head, like how would I do this? You can also just do this straight into Desmos. You're welcome. Did come up. All right, so second. All right, so for this, if say, okay, there's a couple of different ways. So I'm gonna show you probably the easier way to do this, and then I'll show you one other way you can do this because you can actually set up variables defined in here. So let's do a quick way. So you already have this written on your paper, the 12 plus 5 square, 12 squared plus 5 squared, so you can put that in your calculator. 12 squared plus 5 squared, and you get 169, and then you just need to double check, is 13 squared 169? If you get equals for both of them, like if they're both the same number, then you're good. So that's another way you can do this. The other way, a little bit lengthier, but if you have like a bunch of values like those wonderful TEI or TEI questions from Power School, they'll have like 16 different options that you have to pick, and instead of having to enter it over and over again, what you're going to do is you're going to define each of your variables. So you'll define A, which we had as 12, B, which we defined as 5, and C, we defined as 13. Now this one's going to be a little bit different. So now we got those all set up, right? So what I'm going to do is next, I'm going to type in A squared plus B squared, see if that equals C squared, and again, if you get the same answer, you're good. Now, why did I do it this way? Well, I did it this way though, so if I needed to change these, let's say I want to check my old one again, I want to, if I want to check out and see if I did this one right, I can just change those numbers again. So I can make A 6, B 8, and C 10, and do I get the same answer as 100 and 100? Yeah, so that's just using Desmos like this is going to help you if you have a bunch of questions that you have to check for at the same time. Yes, you'll be able to use Desmos basically for the rest of your life. So I would be as familiar as possible. The only thing is, next year's Desmos is going to look like this. So can you do the same thing? Yes. So, square. This one's just a little bit different. You have to put this tab. Oh wait. What was that? 5. Box, you can still do C squared to see if you get the same answer. So it's just, it looks a little bit different. You can still do the same processes in either one, so you'll be good. All right, so I'm going to do one more problem like that. To me. All right, last one. So let's actually do one where we can't get a answer. Where'd my pen go? Got a squared plus b squared, c squared, and the values they give us this time are, oh, it would, now you keep it. So values, it's not, second you'll see the, so values, what did I write? 4, 9, 10. 10, so we'll put 4 in for a, squared plus squared, 10 squared. Remember, always put the largest value in for c. So 4 squared is 16. 9 squared is 81. So if I add 16 and 81, what would I get? Well, what's 6 plus 1? Oh, y'all can't even see that because I'm now just realizing that this is covering y'all. So if I add these, I would get 97. Does that equal 100? Is equal or not? Prompt. So it is not a right triangle. Okay. So those would be the types of questions if you're asked if is it a right triangle, is it not a right triangle? You may be given the triangle, so you may be given shape, and you're like asked, is this still a right triangle? Please still put those numbers in. Remember, the largest goes in there. So they could have given you. Oh, wait up. So they could have even given you this shape, and then just given you. They could have given you those numbers on the side, so they could have given 9, 10, and wow, that is awful for 5 down here. But they could have given you this. Oh, that's right. It's been like a whole week before you've said that. Yeah, so it's not my birthday. It's close. You're getting closer. Um, but they would have given you the shape. Please still put it in to make sure. Even though they might trick you with putting this right angle down here, ignore that. Still check. I don't know if that came through. Um, Alright, so I've locked this down. Let me clear this. Oh, install. Time. Control Z. Second, y'all. I'll lock that. God. Clear the canvas. Oh, it's still taking stuff. Sad. Sorry this is taking so long. Save the pictures. I made graphs and triangles, so it was easier for me just to do the. Anyway, so unlock. I know that took a lot longer. I apologize. So now let's go to work out how to decide. Okay, so out of curiosity, because I have a bunch of problems I was going to do with y'all, would you rather do where we're finding the hypotenuse first or finding the leg first? Nobody? Anybody? Alright, well, find the legs. Okay, that works for me, because I think those are a little bit more difficult. Um, so let's, we're going to find the leg first. So remember the legs are what are next to the 90-degree angle. So if you draw this little arrow, the corner of the right angle to the other side, diagonally across, that's going to be your hypotenuse. So I'm going to make that 18, and I'm going to make this 15. So we have to find this unknown side over here. Okay? So again, you have a squared plus b squared equals c squared. It doesn't matter what you put 15 for. You can put 15 in for a or for b, because 15 is a leg. So it's completely up to you. But as long as you put in 18 for c, you're in the right spot. So I'm going to solve for a for right now. For a, so a squared plus 18 squared, 18 squared. Desmos. I would have Desmos open. Don't already at least use that. I'm going to use that really quickly, and I'm going to bring it up, but it's going to block my numbers. So make sure you have those written down. And they're coming 5, 4. So 15 squared is going to be 225, and 18 squared to be 324. So I'm going to write those numbers down. You're not going to see me write until I 225, 24. Now from this point, what do we need to do? Oh, Taylor, I didn't read the first one. I'm sorry. I miss y'all a lot. I've already said that probably in every done, because it's not the same without y'all's wonderful sense of humor and all the sweet TikToks I've missed out on. This is gonna get too no, both easy, but yeah. So with the legs, this has another step that y'all tend to forget about. So since they're on opposite sides, we need to solve for a. So to do that, we need to do the inverse operations like solving two-step equation. So we're gonna subtract both sides. And when you do that, this cancels. And when they cancel, you're left with a squared equals that. What is? Oh, you know what else I can show you all with this, since you can use this next year. So let's say you don't want to forget these numbers. Press enter. The last number that came up, so this 320, press answer. It will put it in there for you, and subtract 5. And it still gives you the option for that. So it will save stuff there. See if this goes away. It's up there. So are we done though at this point? done with the when we have it just with the a squared. Do we want to know what a squared is, or do we want to know what a is? Want to know what a is, so we're going to take the square root from both sides. Yes, very good, very good. So a squared, the square root of a squared is going to be a. Square root of 99. Let's take a look at what that is. Square root. And again, you could just use the answer, and we'll use the last number that came up, so 90. So 9.9, round it to the nearest hundredth, so the second decimal place, and we're going to make that 9.5. Answer. It's not exact, but it's close, so this would be your answer. And then if you need units, make sure you write that there too. Yeah, I'm sorry. There is still a little bit of a delay. I tried to make the delay as little as possible. Alright, so that's one. Erase this. Boop. And we're going to try one more. Finding the hypotenuse. Let's ring. So this time we're going to do 6 and 17. So if you can draw an arrow from the corner of the right angle across, that's going to be your hypotenuse. So in this case, we're still looking for a leg. And so I'm going to write my Pythagorean theorem. Squared squared c squared. I'm going to plug in, I know I solved for a the last time, and I made this side my a. I'm going to go ahead and put 6 in for b as well, so I can show you that it doesn't matter which side you put it. Squared. 6 squared. 17 squared. Square the numbers. So I went ahead and skipped the next step, so I was gonna subtract on both sides the 36. And that. So if we subtract, we get 253. So I'm gonna write that on. Last step. Is to square root. Square root of 250 is 15 point. So a 15. So that would be our final answer. And again, please include units if they have them, but depends on the problem. I was going to do one with looking for the hypotenuse. And then I just need to take one quick break just to get some water, and then algebra up in a second. So I'm going to, actually I'll do two more. Do two more problems when we're trying to find the hypotenuse, and then start into algebra. Alright, so base all this. Let's get in this crazy, see how this comes out. Make this side 10. Oh, that comes out. Not using that. Ten, 13. Did you have your chart? Cross, we're looking. See the hypotenuse. So my legs are going to be 10 and 13, and it doesn't matter which one you put 10 in for. I'll put in 10 for B. 13 I'm going to put in for A. Again, you could have flip-flopped them and they'd still get the same answer. So I'm going to put these in to Desmos real quick. T squared 10. So 169, and I'll write those down before I take that away. So that down. Now we're going to add them. So that's going to be 269. Again, we're looking for C, not C squared, so we need to take the square root sides. Square root. What's that up? $16.40, so we'll just make it a 16.0. So that answer. Um, that was the answer to this problem. I'm gonna do one more. This makes left side 7. Cross. So we're looking for the hypotenuse. So a squared plus b squared equals c squared. We put 7 in for a, 11 in. Seems like my cut now. Hold on a second. Let's see if that's better. Alright, so 7 squared is 49. 11 squared is 121. So we're going to add those together. The 9 and 121 makes that 130. And the 130 plus 40 makes that a cool 170. So now we need to take the square root of those. So C equals 13.04. So that would be our answer. Alright, so give me 2 minutes. Let me go get some water real quick, and then I'm going to come back with algebra. So I'm going to put the break screen up, and I'll be right back. Alright, so I am back. Alright, so let's do algebra. So for algebra today, we are going to do radical expressions. So I'm going to go through And we're going to do multiplying first. Alright, multiplying expressions. So remember with radicals, when you're multiplying, you have, let's do example, and I'm pretty sure I did this exact problem in class, so I'm sorry if this is a repeat, but if you have something like the square root of 5 times the square root of 10, you can combine these, and so then it's going to be 5 times 10 underneath the radical, and 5 times 10 would be 50. So now you can do one of two things. You could factor this out forever until you get to all your factors, but that's going to be lengthy. What I told you all to do was to write out your square roots, perfect squares, which I'm going to write on the left here. So we have 1, we have 4, 9, whoops, forgot one, 16, and 25, and I'm going to fix that because that looks, and 36, and I'm going to stop there. Are any of these right now a factor of 50, we have to think? I did not know that. So it'd be 25, so I have 25 times 2, and then the square root of 25 would be 5. And we can't take the square root of 2, so I'm going to leave that underneath the radical, so this would be our answer. And what we can do with square roots, we do the exact same thing with cube roots, except with cube roots, which I'm going to green, we would deal with perfect cubes. Can you see this? Yeah, so we have 1, we have 8, we have 27, 64, and 125. I'm not going to do a cube root one today for this. I'm going to mainly just stick with the square roots, but instead of factoring out perfect squares, we would just factor out perfect cubes instead. But the exact same process is going to occur for both. When we get to adding and subtracting, I'm going to show you a couple of reasons why we can't add when the radicals are like underneath, like if there's two radicals, why we can't just combine them like that. But I'm going to get to that in a minute. Okay, so I'm going to leave my perfect squares up. I'm going to erase everything else right now. So if you had a problem like (18a squared times 4 square root of a squared, what I would recommend doing first is to multiply your coefficients. Now remember, outside here, the 18a squared, I would just write an imaginary 1 just so you don't forget. So you could do 4 times 1. 4 times 1, which is going to give me just 4. Oh, you know what? Actually, I forgot to do it this way too. The other thing you can do right here is that you can simplify the a squareds and do it that way, and also the 18 because there's a factor there. But I'm going to go ahead, I'm going to wait. I'll do it that way in just a second. So I'm going to do it when you're just combining them straight off the bat. So 18 times 1 over here, there's an imaginary 1 to that a squared. So 1 times 18 is going to be 18. And a squared times a squared is going to be a to the 4th. Because remember, that's the law of exponents right there. So if you multiply and they have the same base, a and a, you're just going to add the exponents. So that's a to the 4th. Now we have to think about our perfect squares for variables. Remember, they're even valued exponents, so your lowest perfect square for variables is going to be a squared, and it's going to be a to the 4th, a to the 6th, a to the 8th, and then so on. So I could take the perfect square of a to the 4th, so just divide that by 2, which should be a squared, or if you forget, you can just factor out the most basic perfect square, which is a squared. So let's just do the factor way for right now, because we have to factor out for 18 anyway. A perfect square for 18, that's a factor, is going to be 9, and the other factor is going to be 2. 9 times 2 still gives me 18, so we still have our same value underneath the radical. Then I'm going to write out a squared times a squared. Now, if you knew that this was already a perfect square, you don't have to do it the way I'm doing right now. This is just another way to do it. So the perfect square, the square root of 9 is going to be 3. 4 times 3. Cannot take the square root of 2, so that's going to stay there. You can take the square root of a squared, that's going to be a. You can take the square root of a squared, that's going to be a. So whatever's left, you leave underneath the radical. And then simplify. 4 times 3, 12. A times a squared, square root of 2. So that would be our final answer right there. So that's one way. The other way we could have done this is to simplify right off the bat, which I'll put that in purple. All right. So if you had wanted to, you could have or rewrite this just for your giggles. All right. So we can factor out I'm not going to take the square root yet. I'll start doing it now. So the square root of 9, 3. Can't take the square root of 2, but you can take the square root of a squared, so that's 3a times the square root of 2 times 4a, because you can take the square root of a squared. Multiply. And you still get the same answer. So either way works. All right, do another one. Whoops. No, I have not. Not yet. I need to get some peanut butter and some bread first, I guess. Alright, so I'm gonna write in red's gonna be 2. No, they were asking if I had tried a peanut butter and door hinge sandwich yet. So, I don't know. What is the deal with the door hinges, y'all? I don't understand. Did I miss a TikTok or something about it? They're just saying that it's good. I don't know if can I rate that high on this one? Yeah, I can. Yeah, it does sound very crunchy. Square. Oh man, I messed up. Let's try this one more time. So the next problem we're gonna do is -4 square root of 28x times the square root of 7x cubed. Okay, so there's going to be 2 ways that we can do this. So the first way I want to do this is by just multiplying them and then simplifying. However, you could simplify 28 and you could simplify x cubed first before multiplying your radicals. So if we multiply -4 times the 1 that's out here, we're going to get -4. 28 times 7. If we do that, you're going to get 196. X times x cubed is going to give us x to the 4th. And then we can just simplify from here. Luckily for us, 196, if we were to continue out our perfect squares, we would actually get a perfect square right here, and that's going to be 14. So we actually lucked out with having that. So 196 square root is going to be 14, and x to the 4th square root is going to be x squared. So 14 x squared, and that's going to be multiplied by -4. If I multiply -4 times 14, let's do that real quick. -56. So negative x squared. And that's one way to do that. Now let's say you didn't want to do that and you wanted to simplify first. That's fine. So what you can do is simplify what's underneath the radical first. So I'm going to rewrite this again. -4 square root of 28x times square root of 7x cubed. So what's factors of 28 is going to be 4 times 7 and x. And then we can also factor out x squared. So we at least have an even exponent to take the square root, so let's do that real quick. Square root of 4 is 2. Can't take anything else, so we're going to leave that there. Can't take the square root of 7, but you can take the square root of x squared, which is going to be x. So this would be 7x. And then you're just going to multiply. So this is -8, so -4 times 2 is -8. Times x is going to be -8x. 7x times 7x is going to be 49x squared, and that comes out to really easy squares for us to work out with, so 7 and x. So we got -8x times 7 x. X and x is going to be x squared, and 7 times -8 is going to be -56. So we still get the same exact answer. It doesn't matter. It is up to you to decide which one's easiest for you. Even if it's a little bit more work, it's okay. It's whichever best for you to understand the concept. Alright, so I'm going to erase this. I'm going to do now, we're going to do adding and subtracting. So for adding and subtracting, let's do, this is just 2 next that. should help. All right. So all right, so big thing with combining radicals when you're adding or subtracting is that they have to be, the same number needs to be underneath of it. Because remember back when we started, this radical is actually a grouping symbol. And we can't break that grouping symbol until we've figured out everything underneath. So you can't perform an addition or subtraction until this is done with. So as long as they're the same, you can treat them like variables. So if I was to try to, because I originally was going to have like put this back in, but that's going to be a little too much. So the big thing is that you got to make sure that they're the same, and I don't want to get y'all confused when I bring the 3 and the 4 back in there, because I might get a little bit more lost. So you can also think of that we have -3 versions of the square root of 17, and we have -4 versions of the square root of 17. So -3 minus 4 is going to give us -7 square root of 17. And you do not want to add or subtract the 17. You don't want to make that 0. That doesn't go away because this is being multiplied by that. It's the same thing as if we were to have you would still subtract that, so that'd be -7x. We haven't gotten to it yet, but it's also with, if we had factors on the outside, so if you had -3 x minus 2 minus 4 x minus 2, you still have 4 of these and 3 of these, so you could still combine those. So you would have this as, actually let's go ahead and show that. We'll do it this way. So if I was to factor these back inside, like multiply in, so I can combine the 6 and the 8, that's going to give me 14, -4x, and then -3x, that gives me -7x plus 14, right? Now, if I had just added these together, or just combine them like normal, so if I had to -3, so if I got the -7x minus 2, I now distribute that in, -7 times x is -7x, -7 times -2, +14. You still get the exact same answer, so that's why we combine it like that. Treat them like as if they're variables, so they're both the same answer. You can also see this as, we could even factor this out, the 17 out, and if we had factored this, we haven't seen this way. Some of y'all put it on your homeworks earlier, but if we had factored out the 17, so if I'm going to rewrite this right here. So if I factor out a 17, it's like saying -3 minus 4 is left, because I already took these away. I took them back. I'm doing the opposite of when we were doing the distributive property. And then so -3 minus 4 is -7 times the square root of 17 is the same answer. Okay, so there's a bunch of different ways to see that. Hopefully that didn't confuse you. If not, just remember that it's just, you want the same thing underneath the radical when you're adding or subtracting, otherwise you're doing the wrong thing. All right. For the next problem, we're going to do 3 square root of 3 minus the square root of 27. Alright, so right now the radicals are not the same. So we need to factor out something from 27 to see if we get the same. And sometimes it won't, like, we're not going to be able to combine them. We can simplify them, but we're still not going to combine them. Let's see if we can for this one. So we can't take the square root of 3, so this is fine. Our factors for 27, one of them is a perfect square, and it's 9. We have 9 times 3. And we can take the square root of 9, so that'd be 3. Oop, 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 oop. Oh, you know what? This is one similar to the homework a couple days ago too. So this was funny too. So if I have 3 pens and I take 3 away, what am I left with? Nothing, because they're all gone. So that would just be 0. That would be our final answer. You could write it as 0 square root of 3, but anything times 0 is just 0. So just leave it as 0. So that's what we would do with something like that. And feel free to ask questions, y'all. Hopefully I'm not moving too fast today. I'm not sure if I am or not. Alright, let's write in green. I'm gonna do about 2 more problems, and then I'm gonna hold off from there, because then I'm gonna do distributive property with it. I know I told y'all we don't need to do it, but I would like to do it with y'all. And we'll do that on Wednesday. At least that's my plan for right now. Maybe I'll do one still tomorrow. Let me see. But as of right now, I'm gonna plan to do one for at least Wednesday. All right. So next problem, we got 2. Oh, nope, not 2. Oh, we do. Got 2 square root of 6 plus 3 square root of 54. So with something like this, we're going to have to figure out if we can factor anything. We can't factor anything out of 6 because the factors of 6 is just 3 and 2, and neither of those are perfect squares. So that's going to stay there. Our factors of 54, are 9 and 6, so we can factor that out. And please leave your factor still underneath the radical. I think there's a lot of mistakes from the tests and stuff like that with removing it from the radical outside instead of taking the square root. So take the square root of 9 and you get 3. So 2 square root of 6 plus 3 times 3 square root of 6. 3 times 3 is 9. So you have 2 square root of 6 plus 9 square root of 6, and they still have the same thing underneath the radical. So we can combine. 2 plus 9 is going to be 11. So this would be our final answer. Alright, the next one is going to be kind of a lengthy one. So, let's see, I wrote negative square root of 27 minus 3 square root of 45 minus square root of 20 plus 2 square root of 45. Alright, so we're going to look at each one of our factors. Honestly, almost all of them are going to have the same factors that we're pulling out. So our factors of 27 is going to be 9 times 3. Our factors of 45 is going to be 9 times 5. And then our factors of 20. It's a good question. I'm waiting to hear back. I sent an email today about that because you're not the only one who's not taking the test. So I will, as soon as I know the answer to that question, I will let you know. Because everything, like I said, is kind of fluid right now. So we're gonna see what happens with that. Don't stress about it right now. Like I said, this is this is well beyond what we were thinking about months ago. So, but we'll figure it out for you. And that's also why if your grade seems a little bit lower, why your grade may be lower than what you hoped it to be, just because I did put them in as missings if they weren't done. But again, I'm not taking points off for that. I was expecting for us to be there on Monday so we could make it back up, and other things happened, so we'll get it worked out for you. So I factored out everything else. So take the squares of what I can, or square roots of what I can. So 9, 9, 4, and 9. And they are 3. Let me write this as we're doing it instead like that. So negative 3 square root of 3 minus 3 times 3. That is a times, not a, oh, that was awful. Square root of 5 minus 2 square root of 5 plus 2 times 3 square root of 5. So then just simplify. So nothing to simplify here. We got negative 3 square root of 3. Negative 3 times 3 is negative 9 square root of 5 minus 2 square root of 5 plus 6 square root of 5. So anything that has a square root of 5 we can combine. That's just these last few terms right here. So it's going to be negative 3 square root of 3. Negative 9 minus 2 is negative 11. Plus 6 is going to be negative 5 square root of 5. So that would be our final answer for that. And you know what? I said I was going to do distributive property on Wednesday, but I'm actually going to do I'll do one problem with y'all, and I want you to do the other one, if you feel up to it, on your own, and then I'll go over the answer on Wednesday is what I'll actually do. So, I'm going to erase this. So if we had square root of 14x times 3 minus square root of 2x. So you can do this one of two ways. Actually, it's just easier just to do it the one way. So you're going to distribute just like as if you were multiplying. So boop, boop. So you're going to have 3 times 14x minus, put this all underneath the square root, so 14x times 2x. So I'd simplify these. You have 3 square root of 14x minus 2 times 14 is 28, and x times x is x squared. So normally you could say, oh, I'm done, but no, we're not, because we can still simplify some of these. Our factors of 14 are 2 and 7, so we can't simplify those, but we can simplify 28. I want you to think about what those factors would be for a second while I rewrite this. And if you remember what our factors are, they're going to be 4 and 7. X squared, so I'm going to take the square root of x squared. So I have 3 square root of 14x minus 2x square root of 7, and I cannot combine them anymore, so this would be my final answer. Alright, so what I would like you to try and see if you get the right answer the next time is so that's negative 2 square root of 15 times the quantity of negative 3 times the square root of 3 plus 3 times the square root of 5. That's all in parentheses. So I want you all to try that one, and we'll go over that one on Wednesday. And then for Wednesday, I'll see what else we're going to be doing too. Maybe we'll start doing some of the new stuff. At least we'll hit it a little bit before everybody else. We'll get going from there. All right. I do miss y'all a ton, and I hope you're doing okay. And if you have any questions or anything, please email me. You can message me in Classroom. You can use the chat to ask questions and stuff. Don't forget you can do that too. You don't just have to blindly listen or whatnot. I want y'all to participate if you can. And I'll put this up. Yeah. Alright. Love y'all, and I'll see you on Wednesday. Have a good rest of the day.